Mrs. Chairman, ladies and gentlemen, thank you for the possibility to present my second presentation in this conference. This is about the analysis of the notch effect of welded joint. This is our contribution from Slovak University of Technology in cooperating with University of West Bohemia in Pilsen. Short content of my presentation, what is the weld joint, what I mean, this multifactorial notch, I try to explain, then methodology of separation about the main parts of the notch factors, I try to explain, then I present the results from cyclic test of specimen group with not 3, I only select 2 welds for a shorter time, and then some conclusion for practice. Notch factor from welded joint is the multifactorial notch. It's well known that inside the material is very problematic parts like porosities, discontinuities, small cracks possible, also heat affected zone, that change of material properties, and all these things, all this influence, I named technological part of notch. This is this first part from total notch factor, and second is this part of notch which is possible to see, is in the surface. This is the geometrical part. This is classical stress concentration factor. Yes, this is the 2 main factors. What about I try to say, and what about is this study? This is more better explaining in the picture. These are all these technological problems, porosities, discontinuities, intrusion. This is the measurement of hardness, and this is the geometrical things at this notch, this oversizing of that in the notch, root of the notch, root of the weld. Yes, notch factor is defined as a ratio between the amplitude of stress for the same lifetime, same number of cycles. It's logical that this notch factor is not constant, it's the function of a lifetime. It's better to see this first curve. This is the SN curve for first weld I described later. And this notch factor is given for example, for selected 1 million cycles, ratio between this and this amplitude of stress. This is the notch factor. Because this line are parallel, it's logical that this notch factor can't be the constant, can't have the constant value, is the function. For this study, I select 2 type of notch. This is the first, I say that this is the worst weld, is the double V bad weld, it's possible to say. Very complicated for realization. And this first curve, this is the curve from specimen from basic material that feed out the notch. And this second curve is obtained from specimen with weld in the middle of this specimen. This ratio given me this notch, total notch factor. Second, I say that this is the best one, best weld is cut directly from pipe. In the middle of this specimen is the weld directly cut from real operation, from after operation or before operation of pipe. Also, I have 2 lines. First curve is given for the basic material, and this is the curve obtained from this specimen with weld in the middle. Also, ratio of these 2 curves give me the total notch factor. This total notch factor is possible to express like a fitted line. This is the notch factor of this worst weld. This is the total notch factor from this best weld. Also, it's possible to see this range, this scatter of the possibility of notch factors in weld joints. This is the worst situation, this is the best situation, something between exist all other this similar type of welds. This ratio is relatively large because here maximum value is about 2 and here is over exceed 5. It depends of the the technology of the weld, how is possible to see in the next slide. The now is question, this is the total notch factor, how it's possible to compose this total notch factor for these two main parts, this technological notch and geometrical notch. Methodology is based on the three groups of specimen which is necessary to test it. This is the basic material or without the notch specimen, with the weld, and also with the weld, but this weld is removed from surface by grinding, by milling, by torsion manufacturing. Also here, basic material, welded material, and weld when removed this geometry of weld. These three specimens is necessary to testing, and we obtain three curves, three SN curves, and it's very interesting to compare these two diagrams. It's many possible to read from these diagrams. This worst weld, this is the total notch factor. This dashed line, this is the technological. This is the notch factor from specimen which have ground this welded joint. Yes, remove this geometry. And this is the real weld without the removing, with geometry and with technological factors together. Also here are three curves, curve from basic material, curve from welded material, welded specimen, and curve from welded with remove the geometrical notch. It's very interesting that for this best weld, which I said this is the best weld, this line, when I remove this geometry of weld, is similar to the basic material. That this is the very well technology in this weld. Here, this difference between the total weld and weld with remove this geometry is very big. That this technology is worst, it's possible to say. And explaining is in microstructure, this is logical. This is this worst weld, and this is the best weld. This one and the right side, this is the weld metal, this is the heat affected zone, and this is the basic material. It's possible to seems to be very, very similar. This is very good, very well microstructure. This is the good technology of welding. It's possible to decompose from these three groups of specimen, from these three curves. It's possible to calculate. This calculation is more deeply explained here in this paper. Is calculate notch factors, total notch factor, and one part. Technological notch factor, this is this effect inside the materials, and the geometrical notch factor, this is effect which is possible to see. This is the situation or calculation for weld 1. This is this worst weld. It's possible to see that geometrical notch factor can have also negative value. Its explanation why is this possible, I lay this for discussion. From the point P, when become to be positive, this geometrical notch factor it's relatively possible to removing this part of geometrical notch factor. It's possible to removing or enlarge or extend the fatigue life, how I express a little bit later. This is the second weld. This is this best weld. It's also possible to express this line like one line in power kind, but this two parts have the better coefficient of correlation. That also this is a line from total notch factor. This dashed line is notch factor from geometrical effects, and this is this line seems to be one is technological notch factor. This is the best weld which have this very nice microstructure. That technological factor came to be or came to go near to the one. This is absolutely perfect. Also, it's possible to see that somewhere from this point that it's possible to say in the high high cycle fatigue region, it's possible to, by removing this geometrical notch factor, increase lifetime and decrease total notch factor. Here's the, if I know this possibility from 100 and more cycles to the fracture, if it's possible to removing this geometry to decrease total notch factor, now is question if it's possible to predict how high is this geometrical notch factor, not only by testing, because this is very long test, very not so cheap test, that we try to simulate this geometry and find also this geometrical notch factor by simulation. This is the recommendation from International Institute of Welding, main geometrical factor of weld, this radius, this oversizing here and here, these angles. Here is the model. It's very complicated to create this model. This is not so easy way. Also deeply is explained in this paper. It's necessary to have some regularities, this creation of this model, number of elements and the radius, etc. And this is the relation between the experimental and simulation results. That, sorry. Okay. These three dashed line are created by simulation. Sorry, this is the bad name. This is the experiment here. These three dashed are from calculation, from the simulation. This is the simulation for worst geometry, because this combination of diameters in root of the notch, oversizing in end of the notch, top of the notch, and many other these geometrical singularities have many variation how act together. Yes, that this is the worst variation of these geometrical things. This is the best variation in our specimen which we tested. And this is some average. Here is the explaining what is the worst, best, and average. That this is the range from experiment between this line and this line, in where it's occurred the real notch factor for some part of this big notch from pipe or from individual specimen. And this line, full line, this is not simulation, this is the experiment. Yes, this is this line represented by this dashed line, like a geometrical notch factor. This is this line. Okay, that it's possible to say that this simulation is relatively successfully, because these experimental results are inside some boundaries which we create by the all combination of these geometrical problems in weld. It's possible that this is relatively okay. If I know this if I have this information before the operation, give me the information how it's possible to extend, how high it's possible to extend the fatigue lifetime, because remove this geometry, I can extend fatigue lifetime because I decrease notch factor. Profitable is only in the high cycle fatigue region, this operation. It is possible to conclude that notch factor of weld joint is not constant value. Is probably surprising, but this is logical. It must be not constant value. This is function of number of cycles. That methodology of separation of main parts of the notches, this is the geometrical and technological, is given not by 3, by 2 welds. Dependency between technology and welding and the value notch is very strong. Yes, it's presented that this best and this worst specimens is with notch. Then geometrical part of notch factor is possible to remove and thus extend the fatigue lifetime. This is the goal of this study. This is possible, and it's possible to predict this notch factor or pre-calculate it by simulation, film simulation. This is the last conclusion. And when I measured, I very agree with these words from Mr. Lord Kelvin. I try to express this notch factor in numbers because Lord certainly said these nice words. I hope that you are also agree. Thank you for your kind attention.